We may not want land that's rich in humus. I don't think so. But that topsoil, that horizon A, that's the most fertile of the soil horizons. You lose that, you're depending on subsoil and broken down bedrock, which not that conducive, not that helpful to growing plants. Even though, yes, some plants' roots do go down into subsoil as well, but not the best starting point. So deforestation, which is the clearing of trees in an area, taking out of the root system, it's kind of a double whammy because you lose the trees, but you also lose the root system that holds the soil in place. So if there's some sort of torrential downpour, you lose the soil. Double whammy. And it's not like you can go in and say, okay, well, no problem, trees and root system and soil. It's gonna be, in a few days, it's gonna be fine, dude. It's a couple thousand years, it's gonna be fine. But I don't know about you, me. I don't have a couple thousand years to wait for it to be fine. And it tells you right there on page C45, soil takes a long time to form. It may take hundreds to thousands of years for one inch. So if you look from your knuckle on your thumb, to the end of your thumb, that's about an inch. So it takes hundreds to thousands of years for an inch of soil to form. That teeny tiny little bit. So you can think if you dig down, and I think we measured, that was actually measured in centimeters, but, and there's about, if we want to be specific about it, and we get our ruler out, and we can look that in 1 inch, it's give or take 2.5 centimeters. So 2.5 centimeters, we know that our topsoil layer, remember that graphic was about 10 centimeters, I believe? Is that right? Oh no, it was 10 inches, wasn't it? It was inches. It was inches.
8 inches.
Was it 8 inches? Anyway, somewhere between 8 and 10 inches, the topsoil, the horizon A. So if you think that it takes hundreds of thousands of years to create 1 inch, think about how much it would take to create 8 inches of topsoil. So it takes a while. Now as soil forms, different layers result. A layer of soil differing from the layers above and below it is called a horizon. Soils typically have 3 horizons. From the top down they are? Well, no, A, B, and C is right. You're right, A, B, and C. Each horizon has certain characteristics. The A horizon is made up of?
Topsoil.
Okay, that's one thing. Topsoil is the top layer of soil. Makes sense. That's why it's called topsoil. It is rich in humus, humus and minerals. Topsoil is usually dark in color. Most plants grow here. Many organisms live here too. So a lot of your organisms, your burrowing animals, are going to live in the topsoil. Really aren't going to hit that subsoil as much, okay? Because it's a little denser. That subsoil is a little denser. Yes, sir?
Did they mess up on the picture here?
No, because they're showing it in the early stages of breaking down the bedrock. Yeah. And what you're seeing there is it looks like really kind of dry. So the soil is broken down even more when animals burrow through it. Soil begins to form from the bedrock is broken down. Okay. Yes, sir, Stephen.
Why is here there's a big gap kind of?
Well, because that's the way, that may be what the soil profile looks like. There's not necessarily, if you took a soil profile and went out and did a core sample, you may have gaps in the soil profile. Because remember, soil's made up of, well, rock particles, humus, minerals, water, and air. So there are going to be pockets of air in these soils.
And
Yes.
the air might also be an animal's home.
Yes, very good. And the air also might be an animal's home. Did you write the emphasis, Stephen? Yes, ma'am.
Did you when are you ask the people?
I need to check to see when we can get the core sampler. So the B horizon is known as subsoil. Subsoil is normally a fairly hard layer. You might occasionally find a subsoil layer that's a little softer than others, but normally it's a harder layer. It's made of clay particles and minerals that have filtered down from the A horizon. It is usually light in color. Sturdy plant roots may grow down to the B horizon. What do you think some of those might be? Tree. Maybe some of your bigger plants. Bushes, yeah.
Flowers.
Maybe some of your bigger bushes, yeah. Some of your big shrubs.
Flowers.
Yeah, sturdier flowers. Now, again, this is something we might have to research, but we can definitely say trees. Because tree roots are pretty thick.
I've seen a tree.
The sea horizon is made up of coarse material broken down from the underlying bedrock. It is typically, and it says typically, that doesn't mean 100% always, but typically beyond the reach of plant roots. It doesn't mean you won't find plant roots there, but normally, usually, you're not going to find many plant roots. Sorry?
Will tree roots?
It just depends. It just depends. I'm sure there's instances where tree roots have extended far enough down.
Like redwood trees?
I can't say, I can't speak to that. We'd have to look it up to see how, and we can do that. We can look up while you guys are working on this project, I'll look up the root system of a redwood and we'll see just how far down they go.
It's gonna be like broken down.
Well, you think, why do you think that, Stephen? Why do you think that the redwood, and if you don't know, redwoods are our largest trees in the world, sequoia trees too. Why would you think, Stephen, that they would go down all the way down to this horizon sea?
Because like most regular trees go down like the B horizon.
Okay.
And like but these trees are like really big, like 200 feet tall, and that they would probably like.
So
their
Stephen,
roots gotta be like bigger and longer. They need bigger roots to grow.
so Stephen's connection is that the size of the tree should the size of the roots, or should be somewhere. There should be a relationship with the size of the roots, or the depth, how deep the roots go. There should be a connection to, or relationship to how tall the tree is. I don't know.
And maybe
Because
how
some
long-
trees, I always have noticed, some trees seem their roots go out, not necessarily down. Because if you look, we used to have a huge tree in our driveway, and you could see where the root system was breaking up the driveway.
Yeah.
It was going out from the tree.
Oh, yeah.
But again, we can check on that. So while you guys are working on the next project in a little bit, I'll check on the depth, the root depths of redwoods. And so, because those might go deep, I don't know. It would make sense. I mean, I agree with Stephen, it would make sense that they would, but I'm not 100% sure. That's why we can always research. If we have questions, we can look them up.
They might go out.
And they might go out, exactly. They might stretch really far out. It'd be interesting to see.
Yeah.
Yes, ma'am.
And they go out in.
Out and down? I don't know. That's why we're going to look it up. Let's see here. The soil horizons make up a soil profile. A soil profile is a vertical section of soil from the surface down to the bedrock. That's what you've been working on. You made your own version of a soil profile with the top soil, horizon A, subsoil, horizon B, horizon C, the broken down bedrock. And then we didn't put this on your soil horizon or soil profile, but obviously there's bedrock at the base of all soil profiles.
Like the zero
And-
horizon.
I don't know. I don't know if that was what we call it.
That probably like.
The O horizon on that the picture I showed you last week, the O horizon was the organic level. We're just combining that with the A
Is
horizon.
that just here?
Okay. So what we're gonna do now is for tonight, just remember, you're gonna read over these 2 pages. You can watch the Brain Pop video. And if you choose, you may also listen to this discussion that we just had, because I recorded the whole thing.